Okay, let's learn about possibility trees and the multiplication rules in this section. So trees can be helpful to basically take abstract situations and put them on paper so that we can understand what is going on in a specific problem. So in this example 1, it says teams A and B are to play each other until one of the teams wins 2 games in a row, or the team wins a total of 3 games. So that means they don't have to be consecutive games, just 3 in total. And how many ways can the tournament be played? And so if you want to do this like abstractly in your mind, it's going to take a little bit of time. It's going to be kind of difficult to do it. So let's make a tree. Okay, so basically here's what's going to happen. The first game is going to take place. So first game 1, let's call it. Okay, so game 1 is going to happen, and there's going to be one possible winner. The winner could be either team A or it could be team B. At this point in time, since you don't have 2 wins in a row, the tournament is gonna keep going. So next is gonna happen. We're gonna have a game 2. Now in game 2, here's what could have happened. If team 1 won the first game, they can win again, or they could end up losing and team B can win. Okay, so basically each arrow right here represents a winner. So maybe the winner was A, and if the winner was A, then they won again. Well, that means that A has won now 2 times in a row. So that means the game is basically finished. That's it. The tournament is over. You know what? Let me do this. Let me put B on top and A on the bottom just because it looks prettier that way. Now, if the team B has won the game and they go to the second game and team B wins again, then the tournament is now over, we're finished. But if they end up losing the second game and A wins, nobody has 2 games in a row, so we have to continue on to game number 3. So let's go with game number 3. So in game 3, either A, B wins, or again, A or B wins. We don't know, so we're gonna keep going. Okay, so let's think about this for a moment. First game, A won. Second game, if A wins, that's at the end of the tournament. If the A team doesn't win, we go on to B winning, and so they have to play a third game. If we trace along this path of the tree, nobody has won 2 in a row or a total of 3, so the tournament is going to keep going. However, if we trace this part of the tree, B has won twice in a row, so that means B is now declared winner of the tournament and the tournament ends. Okay. So now if we go down below, we said B wins the first game, then wins the second game. That means tournament is over because B has won twice in a row. If we trace this side of the tree, then nobody has won twice in a row or 3 in total. So we have to keep going like that. Then in that case, A would be declared winner. But if we go this way, then nobody has won, so we have to play an extra game. So now we're on to game number 4. Okay, and I keep having to scroll this down and shrink it so that it fits nicely together. But that's whatever. So now game 4. So again, depending on who won the first time, we have to play another game, and maybe A wins or B wins, or maybe A wins or B wins. Okay, so again, that's what's going on in game number 4. So let's see what's happening so far. Okay, if we trace this side of 3, 3 A's are going to show up, which means the tournament is now over. A is declared the winner. However, if we trace this side of the tree, nobody has won twice in a row, and there are no 3 game total wins for any single team. So we have to keep going, basically. And if we go back down, B, A, B, B, B has won twice in a row, so now B is declared winner. However, we trace this tree, nobody is declared winner yet, so we have to play a 5th game. So game number 5 is going to happen next. So game 5. Okay, so there's game number 5 outcome. Again, either A winners or B winner. Okay, so at this point, let's go back to the original side of the tree. So if we trace this route, then in that case, A has won 3 in total so far in this whole tournament, so A is declared the winner of the tournament. However, if we trace this part of the tree, then B has won twice in a row, so B is declared now winner. So that tournament is basically finished. Okay, and what about the other bottom side of the tree? So it's kind of symmetrical. So if we trace this part of the tree, A has won the last 2 games, so A is declared the winner of the tournament. However, if we go along this route, then B has won 3 total games, 1, 2, 3. So basically that means B is the winner of the tournament. And so there is no need for a game 6. All those things that I highlighted are the end of the tournaments pretty much, okay? So these are the winners of each tournament. So this is cool and everything, but I'm gonna make a convenient way of what this means. So I'm gonna summarize this by saying how many possible ways can be played, right? So how many ways can the tournament be played? Let's first make the list and then count the list. So the first tournament is over when AA wins twice in a row. The second tournament is over when B, and B wins that tournament. The third tournament is gonna be played like this: A, B, A, B, A. So this means that A won the first game, B won the second game, A won the third and the fourth games. And again, keep going the same way. So this one is A, B, A. And finally, the last game is gonna be that one right there. So A, B, and B again, okay? And similarly, I'm gonna do the ones on the bottom. So let me go ahead and write them now. So there's the games that can be played, and how many are there? Let's count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So there are 10 ways of playing the tournament. Let's go ahead and write that down over here. There are 10 ways of playing the tournament. And that's the end of part 1 of the problem. So this is what we call in this section a possibility tree. And as you can see, this one was pretty straightforward. It was pretty nice and symmetrical. It kind of looks the same on top as it does on the bottom. So if you kind of fold your page along this line, your sides kind of overlap. They look sort of similar, okay? So it's a nice, very symmetrical tree. Now, assuming that all the ways of playing each tournament are equally likely, so assuming that this tournament here is likely as this tournament there, the question is, what's the probability that 5 games are needed to determine the tournament winner? So how many 5 games tournaments do we have? We have 1, 2, 3, and 4. So there are 4 possible 5 games, and the total number of games was 10. So the probability of playing 5 games is basically 4 divided by 10. And that's 40%. So that's pretty much the end.